Hello. Today we'll have a look at RedisDB approach for velocity metrics calculation. Last time we've considered strict Cassandra-based approach and summarized that it's fast, but there is no any elegant way to calculate one metric by couple of locked attributes. We've redesigned our data structure and added one more data source based on RedisDB to compare our performance. What is Redis? Redis is an open source advanced key value store. It is often referred to as a data structure server, since keys can contain strings, hashes, lists, sets, and sorted sets. But what are the main benefits it can give us? It's simple to understand, and much simpler to work with. You are just putting your data into memory. Since it's in memory storage, it's really fast. It provides a wide range of different storage types that we can use. And of course, it is possible to persist data either by dumping the data set to disk every once in a while, or by appending each command to log. Redis replication is a very simple to use and configure. Master-slave replication allows slave Redis servers to be exact copies of master servers. Let's have a look at our data structure. Here we have two transactions. Each of them has its own set of keys. Each key represents the list of data. For example, there can be multiple payments in a single transaction. In addition, we have a hash data for some transaction extra information, like create date in example. Historical data represented by a simple sorted set of transaction IDs. So we can easily get historical data sets for several different attributes, intersect them, and then get transaction data by the result set of IDs. Using that data we can finally calculate the result metric, according the appropriate configuration. And the same for Cassandra. Here we have our data. Each transaction is represented by a single row, splitted into data lists of different types. We have also added one surrogate historical data key to get raw transactions by time range. Let's have a look at this table closer. Partition key is just a data type plus its value. Row data is represented only by a clustering key, containing transaction time unique ID. So we can get sets of these IDs the same way as in Redis. Metrics table has the same structure as in our previous video. There is only one exception. For multiple primary metrics we have colon-separated partition keys. Let's have a look how does it work in our updated UI application. Here we have the same list of configurations. Let's create a new one for our composite primary metric. It will be email plus form of payment. Metric will aggregate total amount of purchases. And here it is. With some additional information, like last up data, create date, aggregation and expiration periods. Let's check how it works. We will put a couple of credit card numbers. Some test email. Any purchase amount. And card type for each payment. Then send it to web service. As we can see, there is some aggregated data for our credit card numbers, but there is no new metrics yet in the response. Because it has just been asynchronously calculated. Let's send it again, and we will see the previously updated metrics. We can browse our transaction data. Here we can see a couple of our transactions at the bottom. Since we are using history for each attribute, we can use it for filtering. Let's select transactions by some time range. And filter them by credit card number. In addition, filtering it by email, we will see our 2 transactions. Let's have a look at our saved metrics. We have search here instead of filter. It has all the available attributes. Let's find our email metric. As we can see, it has value aggregated from both transactions. If we'll search Visa, we'll see our second metric based on email plus form of payment. MasterCard will give us different metric based on it. Here we have performance test result. As we can see, TP50 is 5 milliseconds both for Cassandra and Redis. But Redis is much faster in general, that illustrated with TP99. 223 against 100. Finally, let's compare the main pros and cons of Cassandra and Redis. As we know, Cassandra is pretty fast. But Redis shows even better performance since it emphasizes in-memory data storage. Cassandra is more strict, and requires an accurate preliminary design of data structures. Redis on the contrary has a very simple API. Cassandra has a very powerful consistency control, which has to be accurately configured on Redis. DataStax provides continuous comprehensive support for Cassandra, and has a powerful tool for monitoring and managing cluster. Redis requires a lot of third-party tools for that purpose. But let me say some words about the current approach for velocity metrics calculation. It has approximately the same speed as the previous one, and allows to lock multiple metrics, to calculate aggregation based on them. But it has the same cons. We still need some background job for historical update with new type of data, if we are going to calculate metric, based on the new attribute. And that's all for now. Thank you for watching.